this one we're going to do a double integral, and it's set up for us with the limits. We'll do dy first and then dx. So when we integrate, we treat x as a constant, so that makes this part easy. E to the xy, we'll just integrate as e to the xy, so it's its own integral. X is a, and the x just kind of comes along for the ride. Using the chain rule, basically remember if you integrate e to the ax, that integrates as e to the ax over a. So whatever this this constant, we have to divide out, because when you take its derivatives, this comes down. So since x is a constant, that's taking the place of the a, we have to divide by x, which cancels out. Okay, so then we just have e to the xy between 0 and 0.1. So let's evaluate that. And again, what we're evaluating is we're plugging in for y. When y is 0, this becomes 0, so that's e to the 0. Let's go ahead and do that. E to the x times 0, and then the upper limit is going to be e to the x times 0.1. Okay. So you got the upper limit, the lower limit. The lower limit is just going to be 1. So we've got e to the 0.1x minus, not e, just 1. Okay, e to the 0 is 1. And we still need to integrate this from 0 to 50 in terms of dx. So when we integrate this, this first part, again, just like last time, it's going to become e to the 0.1x divided by 0.1. Negative 1, when that integrates, that just becomes x to the 1, right? And we take that from 0 to 50. So we'll plug in the 50 part up here. E to the 0.1 times 50 over 0.1 minus 50. So we're just plugging in 50 there. Then we subtract off what happens when we plug in 0. E to the 0.1 times 0 over 0.1 minus 0. Let's see what we get. So 0.1 times 50 is going to be 5, so this is e to the 5 over 0.1 minus 50 minus, this is going to become e to the 0, which is just 1, so that's minus 1 over 0.1, which is 10, right? You divide by a tenth, so that's going to be 10. So this is, let's see, 10, negative 10, and negative, that's negative 60. And this can become up here with 10 times e to the 5th. You can factor out a 10, but, you know, I don't know if this is a perfectly good answer. Or factor out the 10. We've got this. I don't really know why you would want to do that, but that's an exact answer. Alright, and that was question 16, number 17 from the review.